Aloha! Welcome to part 1 of lecture 13. Lecture 13, we are going to cover the formation of the cardiovascular system, which in your book is chapter 14. So the cardiovascular system is the first functional system in the embryo. I do want to point out that on the first page of the chapter, the book contradicts itself by stating that the heart starts beating between day 22 and 23, while in previous sections of the book, it says that it starts on day 21. Now, I looked it up in other literature, and the other literature says that it is day 21. And when I was in college, I was taught that it's day 21. So for purposes of this class, the heart starts beating on day 21, no matter what the book says in this chapter, okay? The heart starts beating on day 21. You will absolutely need to know that for the quiz and for the final. So make a note that the heart starts beating on day 21. You're also going to want to pay close attention during this lecture to the places where oxygen is, because where the oxygenated blood is in an embryo and a fetus is very, very different from where it is in a neonate. In fact, it changes rather abruptly and incredibly dramatically the second that child takes his first breath. So pay close attention to where the oxygen is during this chapter, because a lot of that's going to be on the quiz in the final too. Now, the first thing that we need to talk about is how this heart thing gets there. Right? So you guys remember this slide from way back when. We have a bilaminar disc turning into a trilaminar disc. Gastrulation is happening, and as this mesoderm layer is forming, mesoderm cells from the primitive node and the primitive streak are busy migrating up and around this prechordal plate into the cardiogenic area right up in here. Now, these guys don't just grow legs and walk, okay? They migrate by way of differential tissue growth and, cell budding, So these cells kind of will build on top of each other, and the different layers will grow at different rates, and that will push them up into here, right? So that's how they get there, is by this differential cell growth and cell budding and whatnot. And once they've migrated up into here, they leave behind them this trail of cells called angioblastic cords. Okay, the angioblastic cord, it's going to create a C-shaped band of tissue. You can see it right here, the angioblastic cord. So up here we have this primordial heart swelling, and then we have these two C-shaped bands of angioblastic cord that exist underneath the pericardial coelom. Now, the pericardial coelom is the same thing as the intraembryonic coelom. They are the same structure. It's just that the part that's up here at the top, they call that the pericardial coelom, but it's part of this intraembryonic coelom, okay? Now then, again, remember that these cells are migrating from the primitive node and the primitive streak. So basically what you're going to end up with is a tube, right? These angioblastic cords are going to hollow out into a tube. So you're going to have a tube that is thick up here at the front and thins out as you go down towards the sides, right? A skinnier tube as it goes down towards the sides. At this point, the heart primordium has two halves, and they are not connected to each other in any meaningful way, right? You've got a tube forming over here and a tube forming over here, and they are not connected. Now that's going to change, right? What's going to happen is that the embryo is going to start folding, and as the embryo starts to fold, these two tubes are going to meet in the middle and merge together and form one tube. So you start off with these angioblastic cords, and they're going to hollow out, right? And the embryo is going to start folding. Now remember, you're folding on the sagittal and coronal planes at the same time, right? So the head is folding towards the butt, and the two sides are folding together, and everything's going to meet in the middle as this embryo folds, right? This is all happening at the same time. So this part's going down, and these two parts are going towards the front. All of it's migrating towards the front, right? So these guys are going to hollow out and start to form these tubes, and these tubes are going to stay separate. But as the embryo folds and these two sides come down and meet in the middle and zip together, right? These two tubes are going to come into proximity, and they're going to bump into each other. And as they bump into each other, they're going to coalesce into one large heart tube. Okay? Now, as soon as these tubes join together, the second that happens, this thing immediately starts beating on day 21, right? The heart starts beating and will never stop again until you die. You'll notice at first, you've got just this thin layer of endocardial tissue. You've got this thin layer of cardiac muscle around the outside, and then you've got this really thick layer of this substance called cardiac jelly, right? What cardiac jelly is undifferentiated heart tissue. It is heart tissue that can become multiple different things still, and it's going to differentiate further as the heart continues to develop. Now, while all of this is happening, the body is busy making blood vessels, because after all, what's the use of having a pump if you don't have any hoses to pump the fluid through? All right. So let's go to the next slide here. So by day 26, which is not quite 4 weeks, this is kind of what you've got. Now, what defines a blood vessel as a vein or an artery strictly depends on whether it's carrying blood towards or away from the heart. It has absolutely nothing to do with oxygenation of the blood that it's carrying. A vein flows towards the heart, and an artery flows away from the heart. All right. Now, my thing work here. Sorry about the kids making noise in the background. You know, I have 7 of them. They make a lot of noise. That's just how it is. Oh, one slide too far. Here we go. Now, so there are 3 major veins that we're concerned about. We have up here the cardinal veins, right? The cardinal veins, we have an anterior and a posterior and a common cardinal vein. So the cardinal veins are one. We have the umbilical vein, and then we have the vitaline veins. Now, this umbilical vein right here has the most oxygen-rich blood that exists in the entire embryo. This comes straight from the placenta, and it is the most highly oxygenated blood. I'm going to repeat that one more time because it's going to probably be on a quiz and probably on a final, that the umbilical vein carries the most oxygen-rich blood in the entire embryo. This is where all the oxygen lives, right? The vitaline veins drain the umbilical vesicle, which is eventually going to become the gut tube, right? So the vitaline veins basically drain what's going to be the gut tube. And then, of course, the cardinal veins drain structures from the rest of the body. Okay. I also want to emphasize, well, 2 things. First of all, is that this is only half the picture, right? This is a sagittal section. So this is half of the heart and half of the veins, right? There's a mirror image of all of these veins and arteries. They are all paired. There's a whole other pair, or a whole other set of veins and arteries exactly like this on the opposite side, right? So all of these are paired. There's 2 of each of them. I also want to emphasize that in the end, most of the vessels that you see here in this 4-week embryo are not going to exist anymore. By the time we get to the end product, almost all of these are going to either have been degenerated or integrated into some other cardiovascular structure. Very few of them are going to still be around when we get there. Now, let's take a look at a view from the back of the heart of all the major veins, right? Now, so right here, we've got the left horn of the sinus venosus and the right horn of the sinus venosus, which is what all the major veins empty into, is this sinus venosus, right? These 2 guys are going to migrate together. They're going to meet in the middle, forming the inferior you know, a single sinus venosus, which is eventually going to become the opening of the vena cava, right? So we have the cardinal veins, the umbilical and the Valentine veins that are all emptying into this one or the other horn of the sinus venosus. Now, as these guys migrate and meet in the middle, there's still going to be a left and a right horn of the sinus venosus, but what used to be the left horn is going to become, or what used to be the horns of the sinus venosus is going to become integrated into this common cardinal vein. So we're going to call this the common cardinal vein once they meet in the middle. Okay. Let me see where I'm at here. Right. So, and like I mentioned before, this is none of this is going to stay like this very long. Okay. So let's go on. This is week 7. So by 7 weeks, there's this other pair of veins that have formed dorsal to the posterior cardinal vein called the subcardinal veins. Now, in these pictures, we're looking at the embryo from the front, from the belly side, right? And so these subcardinal veins are forming in front of the cardinal veins, right? As we're looking at it, these would be in front. Now, these subcardinal veins are going to connect to the cardinal veins through several anastomoses, and they're going to form one big anastomosis between the two sides, a common central anastomosis, right? By 8 weeks, oops, I'm sorry, I'm getting ahead of myself. Oh, I skipped a whole section here. Son of a gun. Sorry about that. Yeah, so here are the subcardinal veins, anastomoses, and then the one big central anastomosis. At any rate, so that actually happens at 6 weeks. Right around the same time that these two guys join, these two veins start. Anyway, by 7 weeks, we've got another pair, right? These are the supracardinal veins. The supracardinal veins. So again, we're looking at it from the front, right? So these guys are in front of these cardinal veins, and then these yellow ones are behind the cardinal veins as we're looking at it from the front. Okay. Same thing is going to happen with the supracardinal veins, though. The supracardinal veins are going to join with the cardinal veins through anastomoses. They're going to join right into this big central anastomoses. So you got all these 3 different layers of veins, the back one, the middle one, the front one, that are all joining together in this big central anastomosis. Okay. Now, none of that was as important as this next part anyway. I know I kind of botched that part of the lecture. Sorry about that. But none of that is as important as this part anyway, right? So first of all, the subcardinal veins form, then the supracardinal veins form. But then what happens is the right upper part of the subcardinal vein starts to get bigger. So let's go. And this is going to happen at about 8 weeks, right? The right part of the subcardinal vein here, the right upper part of it, is going to start to enlarge. The right side of the lower supracardinal vein is also going to start getting very large. And then this central anastomosis is going to all start to coalesce together into one great big vessel. And what this is the inferior vena cava beginning to form out of all these other subsets of veins that form along the developmental pathway. Yeah, so these 3 together are going to form the inferior vena cava. Here we go. So we're going to go from this to this. And then these guys are going to continue to enlarge, and these guys are going to continue to coalesce, and we're going to eventually end up from this to this. And we have this inferior vena cava. You can also see on the diagram that most of the other vessels are being used to form other major veins like the iliac veins and the suprarenal veins and the renal veins, et cetera, right? So we got all these other things that are starting to turn into all these other veins. We're not going to go into any great detail on that. So don't worry too much about it. If you're really curious about it, you can look it up in the book. The book has great diagrams, but they don't do a very good job explaining it. They kind of explain it all in a really jumbled I would recommend looking outside of our text if you really want to understand all of this that's going on. But yeah, basically all these other veins are degenerating and being integrated into the other major veins. So let's look at what's happening in a different area of the body. We're still caudal to the heart. This is just a slightly different area. This is in the area where the liver is forming, a little bit further caudal, right? So while all this other stuff is going on, the liver's been busy developing. And as the liver develops, it starts forming these anastomoses within itself. And these anastomoses are going to, some of them coalesce into the liver sinusoids. And they're also going to form the hepatic veins, right? So you have here the vitaline vein that's going to form the hepatic portal vein, right? Now, this is important right here. So you have this the umbilical vein on both sides. There was one over here too. So you have this, and we're looking at the back of the heart. So this would be the right umbilical vein and the left umbilical vein that used to come from the placenta and drain straight into the, oh, come on, brain. Sinus venosus. There we go. They used to drain straight into the sinus venosus, right? But what's going to happen is as the liver develops, there's going to be a very large anastomosis that is going to form between the umbilical vein and the inferior vena cava, right? So the inferior vena cava is busy forming right through the liver, just like it is in the adult, and connecting to the heart, right? Now, you know, this is cut off. There's a considerable distance between these two in real life. They're just approximating them to make the diagram easy. But yeah, so this big anastomosis forms between the umbilical vein and the inferior vena cava. Now, as soon as this connection is made, the rest of the umbilical vein, the one that ran from here to, oh, sorry, darn it, the one that ran from here to there, that all degenerates. And the right umbilical vein also degenerates and just goes away, gets recycled or integrated into other structures. So all that's left is the one umbilical vein that empties straight into the vena cava through this ductus venosus. Hopefully I made that all as clear as mud. Now all of this has happened by week 7 as well, right? So at the same time, cranial to the heart, right? So up here above the heart, you have this big anastomosis that is forming in between the right and the left, sorry, the left and the right cardinal veins, right? This big anastomosis, once that thing forms, most of the cardinal vein is going to degenerate as well. The proximal part of the left anterior cardinal vein is going to degenerate, and what's left over is going to become the brachiocephalic vein, right? So these two guys that used to run this way are going to hook up to each other, and all the rest of this is going to go poof. It's going to go bye-bye, and then this, right, which is now this, is going to become the left brachiocephalic vein. Which is going to drain most of the upper half of the body. Okay? Now, let's talk about arteries for a minute. We're going to start with what things look like early on, and then we're going to talk about how they progress in conjunction with the progression of the heart. So we're going to kind of talk about the arteries and the heart at the same time. It sounds like a lot. It is a lot. It's going to sound really confusing at points, but I'm going to do my very best to try to make it make sense. Okay. Now, as the embryo starts folding, we have the 2 separate heart tubes that are going to merge together into one big heart tube, right? So boom, boom, boom. Now we've got one single heart tube. And meanwhile, you have these structures up here. These are the first pharyngeal arch arteries. The first parapharyngeal arch arteries, as we continue to develop, there's going to be several more pairs of pharyngeal arch arteries that are going to stem from these. All right. So this is a picture at 26 days. And as you can see, we have 1, 2, 3, 4 pharyngeal arches. The fourth pharyngeal arch is still developing, but it's already got a blood supply, right? So we have, oh, I have that wrong. The first pharyngeal arch, second pharyngeal, anyway. So you've got these 4 pharyngeal arch arteries, right? All together, and you'll want to remember this for the quiz, so I'll repeat it a couple times. So altogether, there are going to be 6 pairs of pharyngeal arch arteries, but they're not all going to exist at the same time, right? 6 pairs total, but not all 6 at the same time, right? Now you got to remember also that this picture is only half of the body, right? So each one of these arteries and veins, each one of these pharyngeal arch arteries, all this stuff is all paired, right? So anyway, we have the brain prominence here. We have 1, 2, 3 pharyngeal arches and the fourth pharyngeal arch that is still forming. All of these pharyngeal arch arteries are going to empty into the dorsal aorta, okay? You have 2 aortas at this stage of the game. Remember, one on the right, one on the left, right? But all the pharyngeal arch arteries are going to all empty into this dorsal aorta, okay? Which is taking blood all to the different parts of the body and out to the placenta to get more. Now, as a side note, right, blood going out to the placenta is very unoxygenated blood, at any rate. So as the heart grows and develops, right, the heart tube is going to get longer. But as you can see, this pericardial sac has only so much space, right? You got all this pericardial, anyway, but this heart tube, as the heart develops, is going to get longer and longer and longer. It's going to run out of space. So how does the body usually respond to a problem like this? Right, it folds things. You have a finite amount of space that you got to fit a long tube in, so we're going to fold that tube up. We did the same things with our intestines. We do the same thing essentially with our brain. And that's just how it's going to go. So you'll want to remember that on the quiz, that heart folding happens because the heart tube gets longer than the pericardial sac can contain. All right, so to start off with, you've got this more or less straight heart tube. You've got the pharyngeal arch arteries coming out over here. You've got the sinus venosus coming into the bottom of the heart here. You've got, you know, the cardinal veins, the umbilical vein, the vitaline veins, all this stuff coming into the bottom of the heart here. And what's going to happen is as that heart continues to elongate, the artery side, the cranial side, is going to fold down and to the left. Down and to the left. And then what's going to happen is the bottom part of the heart, the caudal end of the heart, the venous part of the heart is going to fold up and to the right. So we've got down and to the left and up and to the right. Good stuff, right? Let's make sure I got that right. Oh, I totally botched it. So the artery side is going to fold down. Yeah, because we're looking at the front of the heart here. So pardon that. Scratch that. Erase it from your memory. Cranial side of the heart, artery side is going to fold down and to the right because we're looking at the front of the heart, down and to the right. And then the venous side of the heart is going to fold up and to the left, up and to the left. Very rarely this happens in the opposite direction, very, very rarely, and that results in a condition known as dextrocardia, which means that the heart forms on the right side of your body instead of the left side of your body. All right, so here's my little fun visual aid for you guys, right? So this is just a piece of pipe insulation, right? So we're gonna say this is the heart tube, right? So what's gonna happen is that heart tube, as it gets longer and longer and longer, is gonna start to fold. So that the cranial side folds down and to the right, and the vein side folds up and to the left. And you end up with this scrunched up, folded heart tube. Now you'll notice as you look to the sides here, what happens at the folding points is that it creases, right? You see creasing. And a similar thing happens in the heart. As it folds, it creases. And this is part of what begins to form the different chambers of the heart. That's part of how your body does it. So let me go ahead and turn the PowerPoint back on here. Bada bing, bada bang, bada boom. Yeah. So as this heart tube folds, at the folding points, you start to see creasing in the heart tube, and where these creases happen is where the different valves are going to occur. So now this is a 24-day heart, and you can see the chambers already beginning to form as it folds. So you have a primordial atrium here and a primordial ventricle here, and you know, this is going to eventually become the great vessels and all of that stuff. You know, keep an eye on these guys up here. Sorry, let me get to, there we go. So this is at 35 days, and you can see at 35 days, it's already folded up to the point where you can kind of make out roughly where all the different 4 chambers of the heart are going to be. You'll notice this guy right here, this truncus arteriosus. So something you're going to want to remember for the quiz is that this truncus arteriosus is basically going to divide in half, and as it divides in half, it is going to become both the pulmonary trunk and the aorta, the ascending aorta. These pharyngeal arches up here, you're going to want to keep an eye on them as well, because they are also going to play a pretty major role in the formation of the great vessels. But yeah, something you'll want to remember for the quiz for sure, so I'll repeat it again, is that the truncus arteriosus is going to divide in half, and it is going to form both the pulmonary trunk and the ascending aorta. It's going to form both of those structures out of this truncus arteriosus, okay? Now, that's where we're going to cut it off for this half of the lecture. We're going to start talking more about the formation of the 4 chambers of the heart and all kinds of other fun stuff like that. But we'll pick that up at part 2 of this lecture. So that's going to be it for today. Now, I know that was about as clear as muddy water. I tried to emphasize the points that you're really going to need to remember on the quiz and the final. If you have any questions about what we covered today, like I tell you at every lecture, please write those questions down and bring those questions with you to the Zoom meeting on Thursday. I love it when you guys bring me intelligent questions. I really do love it a lot, especially when you stump me. And if you bring me a question that I can't answer, then that will give everybody an opportunity. It hasn't happened yet, because I think probably just the Zoom meeting thing, and I only ever have like 7 or 8 of you at any given Zoom meeting. Anyway, hasn't happened yet. But if one of you brings me a question that completely stumps me, that will create an opportunity for everybody in the class to get extra credit if they want it. So please bring those intelligent questions with you, and let's see what happens. That'll be it for today. We'll see you at part 2 of this lecture later on this week. Aloha.